So this is your lecture on plant identification, specifically tree identification. You're also going to be able to do some identification of flowers, but this one is going to focus mostly on trees and leaves. And so the goal is to be able to use characteristics of leaves to identify trees using the dichotomous keys. And so we should be able to tell mainly the difference between the different types of trees. I just thought this one was kind of funny. The tree smart keeps its clothes on in the winter. So in recognizing the differences between types of trees in our ecosystem. And there's different characteristics that we can use to identify these trees based on their leaves. So we could have coniferous or broadleaf trees. We could be looking at the leaf structure. We can be looking at the arrangement of the leaves on the stem, the shape of the leaf, on the outside edges of the leaf, which could give us a good idea of what type of leaf that is. We could look at the veination, and if they're coniferous, we could be looking at whether it has needles or scales, or if it does have needles, what is the bunch size, which is going to tell us what type of specifically pine tree that we're dealing with. If we look at a leaf, there's three main parts that we're going to be talking about. The blade is basically the part that you would think about as your leaf, which is going to collect the sun's energy and do photosynthesis. And you're going to have, and that's where we're going to have a lot of our identification is going to come from. You have the petiole down in here, which is basically this little part sticking right off of the leaf that's going to turn this leaf towards the sun to collect more energy. If you've ever seen trees before, I always think it's cool if you're down in a valley, maybe if you're fishing a creek or something like that and you're standing in the middle of the creek, you can see how the trees kind of bend in towards the middle so that they can get more sun, and it actually spreads the trees out on the side of the creek. And it's interesting to me how trees will try to find, and plants in general will try to give themselves the best angle for getting sunlight. And they'll do the same thing with their leaves. Well, they'll turn these leaves toward the sunlight as it moves throughout, kind of like if you've ever seen like solar energy panels, where they'll move the solar panels to follow the sun throughout the sky, so they'll be getting the most sunlight energy possible. Trees will do the same thing with their leaves, and that comes from the petiole, which can move those leaves towards the sun. And then you also have these little nodes here, which attaches the petiole to the stem. And the node is going to help us to identify whether we're dealing with a leaf or a leaflet as we're identifying our trees, and we'll get into that in a little bit. So once we look at the actual leaf, we can tell, does it have broad leaves or does it have narrow leaves? So broad leaves would be these flat, wide leaves that have veins visible, and then the narrow leaves or coniferous could either be scaly or they could be needle-like, and the needles could come in bunches. So that's the first distinction that we're going to make, because you're going to use different classifications based off of that. So is it broad or is it narrow leaves or coniferous? And then once you decide that it's broad, we're going to be looking at the leaf arrangement. And so we have the first arrangement right here, which is alternate, where these leaves are alternating on the stem. They're going every other. And we could also have leaves that are opposite. If you can see these, this is actually a black walnut. If you zoom in on these little leaflets here, they do look like they're alternate, but this picture shows it as it looks exactly like opposite. And so they're growing straight out from one another on this stem, and they are opposite one another. And then you have a whorled leaf arrangement where you have, in this case, 4 different leaves coming out from the same point on the stem in different directions from the stem. That's called a whorled leaf arrangement. That's one way that we can identify our leaves. And so once we get that done, we can decide, is this a simple leaf or a compound leaf? And as you can see with the simple leaves, there's one blade and one petiole. So you can see there's a little, I mean, you can't really see it on here, but there would be a little petiole here. You can see that little nub sticking off the end of the leaf. One blade and one petiole, and those are our simple leaves. And then you have your compound leaf, where you have one petiole right here, and then you have the leaf coming out, and you have little leaflets that come out from the main leaf. And an important distinction between a simple leaf and a compound leaf, one way to tell if you're dealing with a compound leaf with leaflets or you're dealing with a stem that has a bunch of leaves on here, is whether or not it has a petiole right where that leaflet comes out from the stem. And so if you look on this picture especially, you can see a little petiole here, and you can see that there is no petiole coming out from this leaflet. They don't have them. And the same thing down here. We'll zoom in on that picture later. But they don't have that petiole that we normally have. So that's one thing to look for here. And so this is basically an idea of what a simple leaf looks like. It has all the structures that we've seen before. One blade, one petiole, And then as we look at compound leaves, we have a couple of different types. We have pinnately, where there's one main stem, you could say, coming through there. I think the word that they used was rachis, coming down from this leaf right here. And then you have little leaflets coming off of this. This is called pinnately compounded, as in there's one main part that they are all coming off of along the length of that stem, you could say. You have twice pinnately compounded, where we have the one main part, and then we have little rachis coming off of that, and then leaflets off of that. So this is compounded twice. And then we have palmately compounded. You can look at the palm of your hand, how your fingers all stretch out from the middle of your palm. These little leaflets are all coming from the same point on this leaf, and so we would call that palmately compounded. And here's an example of a black walnut leaf. You can see this hopefully a little bit better, that down here we have this little node right here that says that this is the leaf. And as you look at these little leaflets coming off of here, you don't see any of those nodes. They're just growing straight off. And so that tells us that this is a compound leaf, and these are leaflets and not individual leaves, because they do not have a node. So once we decide whether it's alternate, opposite, whether it's broad or narrow, whether it's simple or compound, we can look at the margins of these leaves. And there's a lot of different types of margins that we can use to identify these leaves. We can have an entire leaf, we have a serrate, we have undulate, we can have lobed, and these are the main types that you're going to deal with. You can see how this one is smooth along the length of the leaf. We have serrate, which means we have these little spikes that are sticking towards the tip of the leaf. Serrate looks like a serrated knife, where you have a little, you could say teeth, you could say. We have undulate, where we have the little waves, but they're sticking straight out. The tip of them is sticking straight out, and so that's undulate. If I drew a 90-degree angle off of this leaf coming straight out of the tip, it would be pointed in this direction, where the serrate would be pointed forward. And if we have lobe, this looks like an oak tree. Right here you have these deep cutouts into the leaf, putting them into specific lobes. And here's a lot more different types of margins, but like I said, the main ones are entire, serrate, dentate, and you have lobed as well. And you can see how lobed could be different types. You could have pinnately, and you could have palmately lobed, like a maple tree right down here. And so the margin is going to be basically the shape of that leaf as you're looking at it, and that's going to help you to define what type of leaf it is. And then you can look at the vein pattern. So the vein pattern is these little veins that are running through. What shapes are they in? And you can see we have a wide variety of them here that actually give the leaf quite a bit of character and help us to identify what it would look like. And so there's three main types. Parallel veins are going to be traveling parallel along the length of the leaf, and they're not going to touch each other. So you can see how these ones go straight from the top of this leaf all the way to the bottom without crossing over each other, and they're not coming out from one point on this leaf, as you'll see in the pinnate one. So pinnate, we have one main vein down here. We have little veins branching off of it. So you can see the difference between these two, especially here. This one would be mostly in ferns and tropical plants. We probably won't see a ton of that in our studies, but pinnate we will see a lot of. And so you have one main vein coming down and little veins branching off of that. It's elliptical, and they're kind of feather-like. So then you have your palmate veins, where again, palmate, all of your fingers are branching out from the same point, your palm. And right here you can see how all of the veins on this leaf start from this point right here, and they all branch off from there. Now we have a little bit that looks like, this part looks like it's pinnate if we just looked at that, but we also have other main veins coming off of here. So we have 1, 2, 3, 4, 5 in this maple tree right here. And then if we have our conifers, we can see that we have either needle leaves or we have scale-like leaves. The needles are going to be a lot more sharp and pointy, and the scale-like leaves are going to look a lot like scales on a fish. And once we decide that we have needle leaves, we can see, are they single needles? Are they in bundles of 2 or 3, like we have right here? Are they in clusters, like we have right here, more than 5? And that's going to help us to define that. So once you decide that you have needles in here, you decide, okay, are they in bunches, are they singles, are they in clusters? And that's going to help you decide. One of the main ones that we're going to see is red versus pine. And the way my dad taught me this was, if you count the number of needles in the bunch, red is going to be R-E-D. You'd always count R and E on the same needle and then D. R-E-D. So there's two needles in a bunch of red pine, and white would be W-H-I-T-E. There's 5 needles in the bunch of a white pine. And if you have any other ways of remembering the red pine, if there's a better way of describing this, please let me know because I've been using that one for my entire life. But it just stuck into me because as a kid I thought it was so funny. R-E-D. And I sat there and looked at him for a while and was like, what is he talking about? There's 2 needles. But that was the joke behind it. R-E-D. And then W-H-I-T-E. So you can tell the difference between types of pines based off how many needles are in the bunch. And so once you get into scale-like leaves, they're going to be small, they're going to be short, they have overlapping scales, and you're going to be able to tell the difference between those. It's very specific types of trees like cedars, junipers. You probably won't run into any giant sequoia trees in your ecosystems that you'll be studying, but you can definitely identify trees based off of those scales because it's a very select amount that you're going to see like that, especially around here. So that is the presentation on leaf types, being able to identify those leaves, just to give you an idea of what all those characteristics are as you're going through your dichotomous keys in your ecosystems, identifying what types of trees are the main types that you have in your specific ecosystem. So if you have any other questions, make sure you ask for help and you ask around as you're going through your dichotomous key. And if you give some practice to it, check a tree, go back, look at it, you'll get the sense of this pretty quickly, I think.